Okay, we're looking at Pre-Calc section 6.3, Sum and Difference Identities. The sum and difference identities can be used to find exact values for the trig functions of certain angles, and what we're looking for with exact is these are values written as non-decimals, and they're going to be in forms that are using radicals. We can also use them to simplify expressions, and like you've seen in the previous sections, to establish additional identities. Okay, so we're going to have three groupings of sum and difference identities. You have the cosine family, so if you have the cosine of the sum or the difference of two angles, that alpha and a beta. So you're going to notice here that the functions repeat. So if you track, that's just written in reverse, or the these fine. Numerator, the signs are going to stay the same here. From section 5.2, looking at those trig functions of special degree 3. And quadrant 4. This is the all-star trig class, or all students take calculus, to help you figure out the signs of the particular trig functions. So let's take a look at an example. So we want to find the sine of 75 degrees. So 75 is not a special angle, but it is the sum of two special angles, 30 and 45. So we can rewrite this as a sine of 30 degrees plus 45 degrees. And you'll see here that 30 degrees, let's call that alpha, and 45, let's call that beta. So if we go up to our sum identity, sine sum identity, we're going to have the sine of 30 degrees times the cosine of 45 degrees plus the cosine of 30 degrees times the sine of 45 degrees. And if we look up the values in the table, the sine of 30 degrees, or if you remember those, that's 1/2. Cosine of 45 is the square root of 2 over 2. Plus cosine of 30 is the square root of 3 over 2. And the sine of 45 is the square root of 2 over 2. And then we're just going to simplify. We end up with the square root of 2 over 4 plus the square root of 6 over 4. Common denominators of our fractions, so we can just combine the numerators. So we get the square root of 2 plus the square root of 6 all over 4. And that is our exact answer for the sine of 75. Just a word of caution that we can't just distribute the sine to the two angles in the parentheses. That's not what the sum and difference formulas are. So if you just double check this, we just found this to be the square root of 2 plus the square root of 6 over 4. And we can clearly see that the sine of 30 degrees is 1/2, and the sine of 45 degrees is the square root of 2 over 2. If we add those together, because they have a common denominator, we get the square root of 2 over 4. Those are not the same solution.